Alright, so we're going to take a look at creating linear equations from tables. So first a couple little bits of definitions and things like that connect with it. So first is the slope. So we're going to look at the term slope. Slope is also known as the rate of change. Slope is represented by the letter m in our equations, and slope has a calculated formula of taking y1 minus y, or y2 minus y1 over x2 minus x1. And what that is if you're given 2 points, x1, y1, and x2, y2. And this terminology gets really confusing for a lot of students, so don't be concerned if you're not getting it right away. Make sure you're asking for help, because this one can be really confusing. Most students have difficulty with the idea of variables, never mind that the variables have these little numbers with them, and it's not y times 2, but it's actually y subscript 2. So that if we write it really big, it's not y2 like that, it's a y with a 2 down here. It's kind of like an opposite of a power. It's used just to note that they're both y values but different y values. And so this idea of slope anyways, or rate of change, is it's really on the graph, it's the directions from one point to the next on the line. Or it's a numerical description of steepness. So if we're looking at this little graph I made down here, it's how steep is that line? Is it very shallow? Is it very steep? Is it going up when we go left to right, or is it going down as we go left to right? So if we take a look at this line here and our slope on there, our slope is the directions from one point, say here at 0 and -1, to another point here, say at 2 and 1. So how do we go from one point to the next? Well, we're going up 1, 2, and over 1, 2. So we go up 2 and we go over 2. Now my graph isn't perfect and the lines might be a little off because of the lack of a ruler on the marker board here. But we're going up 2 values, we're going over 2 values. So the slope is the change in y over the change in x. So we can also use the term, it's the rise over the run. So we rise up 1, 2. So we rise up 2, we run over 2. So our slope in this case is the 2 over 2, which would be 1 over 1 if we simplify that. And so our slope is the change from those different values on the graph. So we have those 2 points, and it's the slope here of 2 over 2. And so that's how steep it is. Again, simplifies down to 1 over 1. So that is our slope. And it just tells us that for every point that we move over 1, we go up 1. Or every time we go up 1, we have to go over 1 to stay on the line. So we go up 1, over 1, up 1, over 1, up 1, over 1. And it's kind of like what the stairs would look like built on that top of that line. And the other point that's key for us is the y-intercept, and that is where the graph crosses or intercepts the y-axis. So this is a y-axis all the time, an x-axis. X is always left, right. Y is always up, down. This point here where it intercepts the y-axis, that is the y-intercept. I spelled that clearly. Intercept. So there's our y-intercept there. It's just looking at where the graph is going to cross. Now, in our case, we need to look at how do we calculate these values, these pieces of information from a table, so that we can then take that table and make an equation that can find us any point. And what's the purpose of, why would we even do this? Like we don't need the equation. The equation's to find any point on the line given any value. And where would you never use this in life? Well, you'd never use this in a business practice where you actually can look at your cost analysis and say, okay, where do we actually make this much money? Or if we sell this many items, how much money will we make? Well, it doesn't seem like that even connects. They are very related to things like linear and other graphing equations. So the actual application of this for our example here, let's take a look at a little table. We'll have an X and a Y, and we will use 4, 6, and 8 as our X values, and our Y values we'll use -2, -7, and -11. So in this case here, sorry, this is -12. So in this case here, we need to find our slope, we need to find our y-intercept. So the question might be, make a linear equation from the table. So a linear equation is a y equals mx plus b. These are the two values we need. Y and x are going to just stay as y and x in this equation. So we need to find out the m and the b. The m again is the slope, the y, and the b is what represents the y-intercept. So the b is the y, what we use to represent the y-intercept. So calculating this out is two parts. One, we need to find the slope. So for the slope, we pick 2 points. So we need 2 different points. So here's one point on the graph, here's another point on the graph. I'm going to call that 1, and I'm going to call that 2. So point 1 and point 2. So the equation is y2 minus y1 over x. Let's get a better x there. x2 minus x1. Subbing these in. How do we sub these in? So we'll call that m equals. Well, y2 on the chart here, y2 is -7. So that equals -7. y1 is -2. So it's -7 minus -2. Notice this is a minus. This is one of the things that trips people up with this equation. That is a minus, so it is a double negative there. And then x2 is 6 minus x1, which is 4. And we can calculate that. 7 minus -2, that's like a plus. 2 negatives side by side like that make a plus. So 7 plus 2, -7 plus 2 is going to be -5. And 6 minus 4 is going to be 2. So our slope in this case is -5 over 2. So thus far we can replace this m with -5 over 2. Now the next part here, we need to find the b value. And to find the b value, we have to take this equation now and substitute in one of those points. So I'm going to get rid of this. So this equation is the goal of this equation is to tell us these values. It's these values here tell us, or the equation is going to calculate these and then any others. So if I put 10 or 12 or 11 or 13.3792, those values in the table, we can, if we know an x, we can find a y. If we know the y, we can find the x, and that's what this equation is going to do. So we can take one of these values out of the equation, sub it in, and find the b value. So if we pick the small numbers here from number 1, I'm going to sub these in. So I have a y of -2, and I have my -5 over 2. My x in this case is going to be 4 plus the b. So we can simplify a little bit here. -5 divided by 2 times 4. So in that case there, what we're going to get is -10 plus b. And now we can simplify this and recalculate this by moving this part over to the other side. So solving for b, -2 plus 10, we do the opposite operation, we move that over, equals b. -2 plus 10 is going to be 8. That equals our b value. So there's our b value. And now we know our b value, we can sub that in up here. So our b value is 8. There is our equation. Y equals negative 5 over 2 times x plus 8. And that there will find any other point on the graph. So if we subbed in any of these numbers, we would get that same result. So if I put the 8 in there, we'd have negative 5 divided by 2 times 8. We would end up with negative 12 as our answer when we calculated that out. So that's what that does. And we can find any other point on the graph as well. And it'll be with that. So a little bit of a bigger lesson, a whole bunch of different things in here. So you might want to take a look at this a couple times. Ask for some help, ask some questions, make sure you understand that this one is big. This one covers grade 9, this goes into grade 10, and there's a lot of questions, as you may have noticed, on the EQAO test as well with this.